So just a bit, I spent most of my career with the University of California, but I do now work for the Insurance Institute for Business and Home Safety. We are a nonprofit funded by the insurance industry, and the insurance industry would like to reduce their loss and by helping you make decisions on how to make your homes resist natural hazards, wildfire being one of them. So we have a large, pretty new wind tunnel laboratory in South Carolina, and where we can do high wind, rain, fire kind of exposures and learn about vulnerabilities of buildings, and more importantly, learn about how to fix the problems that we see. So we try to incorporate what we find into building codes and the like, but one thing that we do is try to outreach to you so that you can do things before the event happens. And if you're like me, you already live someplace. So a lot of what we do is aimed at helping the person that already has a place to live, how to make that place more durable, better able to resist these natural hazards. So we're going to be talking about wildfire exclusively tonight. Your home has to resist these 3 exposures. These are sort of common wildfire exposures. There's the firebrand or ember exposure. These are the small burning particles that are blown in front of the wildfire. It's not, they themselves can accumulate and ignite combustible materials, but more importantly, they can ignite finer fuels that might be at the base of your siding or on top of your roof, or get into your home through open windows or attics or attic vents and ignite things there. So embers are really important because of what they do, and they ignite things directly or indirectly. The indirect fire, typically wildfire doesn't burn right to a given house. It's these ember things embers that ignite other things that might be vegetation on your property or whatnot. So the other 2 components that the house has to resist, or your home has to resist, would be a direct flame contact exposure. This is the most threatening thing to your home. If flame touches your house, it is more vulnerable. It just is. And then the third thing is radiant heat. And that would be like standing in front of a wildfire. And so how important that is a function of how big the fire is, so to speak, and how long does it stay there. And typically, vegetation doesn't burn very long, but if it's your neighbor's house or your tool shed, that doesn't move, it stays put once it's ignited, and it burns for much longer than a plant. So, how important radiant heat will be a function of what's burning and how far away is it from your house. So these are just pictures of the things, so up the top left would be an ember or firebrand exposure. This is in our test lab in South Carolina. You see these embers being generated. The ember generator is below the ground, and we're burning mulch and wooden dowels, and then there's a fan underneath the ground that blows them up through this fire chamber into these vertical ducts that then send them into the wind stream of the wind tunnel. And then we evaluate how they impact the house in this case. So this is an ember exposure. We'll see some pictures and a video clip later on. The flame contact, it can be the broom on your deck, it can be a firewood pile next to your house. Anyway, or it can be debris in your gutter. The direct flame contact exposure is the most vulnerable that your house will see. The third is shown in the lower left with the radiant panel. This is a laboratory kind of a piece of equipment. We'll talk about this a little bit later, but it is this heat exposure that isn't a direct flame contact. It's just the heat from, say, a fire that would be at some distance. Okay, and so this is those of you that have read a little bit about wildfire certainly know the name, I think, of Jack Cohen. This is his research study in the Northwest Territories of Canada, where he was looking at crown fire. And this is just to show you this left-hand axis here is the radiant heat exposure, and the bigger number, the worse the exposure. In order to ignite wood, for example, you need to get about the number 20 for minutes, not seconds, but minutes. And we're seeing here that in this wildfire burning next to this structure where the heat flux was measured, it was about 100 yards away. The heat flux was high, but for a short period of time. So you might char something, but it wouldn't continue to burn. But this whole thing changes if it's your neighbor's house that's burning, or your tool shed, or or firewood pile for that matter. These things will burn much longer and so prevent a much more severe exposure to your house. Okay, so homes survive wildfire because you've done two things, and it's hard to say which one's more important. You've done things to the vegetation on your property, and you've done things to your house. In this case, if you can imagine that you've done everything to the vegetation, so you have bare ground between your property line and your house, but you ignore your house completely, then your house will be vulnerable to ember exposures. So it's still vulnerable. If you ignore your vegetation and do everything practical for a house, the fire can still burn directly to the house. You'll have a direct flame contact exposure to the house, and it'll still have a hard time surviving if it's a house that you choose to live in. So protecting your home and having your home survive is a coupled approach where you address both vegetation and your home and building materials. We're going to focus on the home tonight and talk about that. But we at IBHS really advocate for a three-zone approach to vegetation management around your home. This is not a home that I saw today because of the terrain, but in concept, you want to have this non-combustible zone right next to your house, within 5 feet of your house, and then the other zones from that 5-foot zone to about 30, and from 30 to about 100, or your lot line. You want to do things that just minimize the opportunity for ignited vegetation to either reach your house or give a big enough radiant exposure to damage your house. So the next talk in this lecture series, we'll be talking a lot more about vegetation. So I'm just going to kind of leave it at that. The other thing that I observed today, and it sort of goes against this slide because it's such flat land, but there was a study out of Australia that looked at home survival as a function of where it was on the slope. And if you can see here, if you are at the top of a slope or mid-slope, the homes that are lost are sort of in those locations. So if you're mid-slope or at the top of a slope without much setback, that just means that that your job is to have even better defensible space so that the fire, the flame length of the fire burning up the slope won't be able to impact your house or allow heat to build up onto your deck or things like that. So if you're in this category, then your defensible space sort of concerns are exacerbated. Okay, so we're going to talk about the house, and we're going to talk about it from the roof down, so roof, walls, and then decks and other attachments. So there's a lot of components. We're going to spend a fair amount of time on the roof because the roof, your roof, is the most vulnerable part of your house. And so we'll talk about what makes it vulnerable, for example, and then we'll talk about other components. Before we do that, we're just going to spend a minute talking about materials that are on the outside of your house. So these are terms that I think we sort of banter about that describe how well things burn. So we have things that are combustible. Another word that we might use interchangeably with that would be flammable. And then we definitely have non-combustible and or non-flammable, non-combustible, non-flammable, fire resistant, ignition resistant, flame resistant. Are there other terms you've heard that you think that help you understand how things burn or what you want? If I were to ask you to name me one ignition resistant material, can you help me do that? Hardy board. So hardy board is a fiber cement product that is non-combustible. So if we have non-combustible up here, it would fit into that category, and so therefore maybe also into ignition resistant. But it has a place in non-combustible. We use ignition resistant a lot, and there aren't that many products that actually are that, the way that it's defined in the code and by various standards. Any other? Stucco, non-combustible. So it's in.
What about wood that's, say, 4 inches thick?
So wood. So the comment was, what about wood that's 4 inches thick? And so I think we're getting here into this thing maybe called heavy timber or whatever we want to call that, and it's harder to ignite, but it's definitely still combustible. So the one thing that is meets the definition of ignition resistant is fire retardant treated wood, though. So, that can be ignition resistant because it meets that definition. Things that are done to wood. So ignition resistant is still a combustible material. It's just that it's less so. So we're going to be talking about these kind of things along and along. I just want, I just want us to sort of get on the same page. Most things or many things on your house and in your house are combustible. And so the trick is to, if you have these components, is to do things so that they aren't as vulnerable because the fire can't get to them. So here's your roof. And the red circles and the yellow boxes are to indicate that there's things that deal with the field of the roof where there's nothing next to it. And then there are parts of the roof that can make it vulnerable because of what it's next to. So, so this is a demonstration that I learned from a famous building science guy named Joe Stiberick. But so how many of you have a roof that looks like this? Okay, so this is a simple roof. It has two edges. It has the field on both sides. It has two edges where you might hang gutters, here and here. These are called the eaves. So, and then how many of you have a roof that looks like this? So this is, it has dormers and split level kind of house. So this, so yeah, got it? Okay. So this is called a complex roof. Okay. So if you have a complex roof, then you have other things to worry about, and we're going to talk about those other things to worry about during the course of this deal. So we're going to talk about the field of the roof that, mostly if you have a simple roof, you're worried about the field of the roof kind of issues. And then if you have a complex roof, you're worried about these other things. So this is a roof test, and this is what it looks like to have a roof, your roof. It would be like going up on your roof and cutting out a 4-foot by 3-foot section with your chainsaw and then taking it to a lab and putting some sort of burning thing on it and waiting to see whether you have fire, that starts out on your roof, whether it turns out coming through what would be your attic. If this happens and you don't have a class, you name it, roof. So there's 3 basic kinds of roof covering fire ratings, A, B, C. How many of you have heard of those guys? So class A is the best, B is not as good, and C is worse, and non-rated is less than that. So this is a class A brand, and this is the same roof. So as built, this is not a class A roof. And these are the brands that are put on a burning one of these guys, put on the roof. So this is a 12-inch by 12-inch series of 3/4-inch sticks that are nailed together. It's in a 3-layer sandwich construction. So there's a bottom. So the middle one goes perpendicular to the top and the bottom. The B brand is 6 inches by 6 inches. and then the C brand is about the size of an ice cube. And during the course of the test, you put out 20 of these C brands on the roof, but it's still not nearly as severe as the A or the B. Okay, so if you have a Class A roof, that means you can put the burning Class A brand on the roof and it won't burn through into what would be your attic. So it doesn't burn through the roof deck into the attic. Okay, so that's how we get the fire rating. So if you have a Class A fire rating, it can withstand this kind of exposure. And then there's, to maybe complicate matters a little bit, there's a standalone fire rating and a by assembly fire rating. So if you have a by assembly fire rating, that means you have stuff below, material below the part of the roof that you see that helps the test. So in this case, this white piece of material is a gypsum fiberglass product. So it by itself is a Class A fire material. So it shouldn't care what's on top of it. And to a large degree, it doesn't care. And so some products need this in order to get the Class A fire rating. So common examples of this would be a fire retardant treated wood shake roof. You can get a Class A by assembly. But similarly, by the aluminum roof covering, because of its melting point being so low, that it needs a by assembly rating also. So even though it's non-combustible, it still needs to have this extra material to get the rating. And most of the newer recycled, the roofing products that contain recycled plastic and rubber kind of products, they need the extra to get the by assembly. They can only get a by assembly Class A. So, so this is, when you're looking at roof for your house, you want to know, is it a Class A, and if it is a Class A, does it care? Is there a certain assembly that needs to be made? This is, you got to read this because it's either humorous or not. But the point is that you need to follow directions and use the material that is specified in the to make sure that you build it the way that it was tested, because that's the way that it passes the test. If you think that a particular product isn't going to matter, often it does. So, you park your car in a no parking zone, what's the worst that can happen? A ticket, angry look. But if you build the roof different than the way that it's said to, then the result could be a little more severe than that. So, okay, so here we are, the exposure to the test building in our lab. And we're going to start talking about some of these complex roof issues. So here's a wood shake roof, untreated. You notice that that at this point it isn't one large fire over the entire roof. It still started sort of small fires. And most wildfire home losses occur because a small fire gets big. So you have a small fire that starts someplace in or on your house and it gets larger. This is the same thing that happens here. We're going to look at this circled area here. And this is after we put the fire out before it got too bad and then undid the roof, so to speak. And at one location here, it burned through the roof sheathing into the attic. So you would have had embers and fire dropping into your attic, igniting things in your attic. You would have had an attic fire, and an attic fire isn't such a good thing to have a home survive with. So that's that. We have, this is a valley. So what we're seeing now in this picture is an asphalt composition shingle. It's a standalone Class A fire-rated roof. This is a valley. So in this case, the shingles were woven together so that you don't have the metal flashing in the valley. Debris built up in the valley. Clearly, well, you see on the lower right-hand picture that the roof survived. It was damaged, but it did not burn through. So the pine needle loading on an asphalt comp roof, it can handle it in this case. So you might be replacing your valley, but I think most people would prefer to replace part of your roof covering, maybe a window. Replacing your home is a different kind of a different level. I think everybody's happier with damage, minimal damage versus total destruction. And here's another example of a complex roof issue. This one's more severe, I think. Here we have debris buildup on an asphalt comp Class A roof, and what's next to it. So it is a wood shingle siding in this, split level kind of a house. So we already saw on the previous slide that if embers ignited, in this case it would be leaf debris. From the Class A roof perspective, it's not such a large deal, but does the siding offer the same protection that the Class A roof does? And in this case, it does not. And so the vulnerable part of this roof isn't the roof covering, it is the thing next to the roof. So when you look at your roof, you got to look at the roof and what the roof touches in order to determine how vulnerable your home is really. So this is, again, the bigger picture here is a test from our lab where we had debris next to the siding of this dormer. And then the inset picture is a neighbor's house next to where I live that has wood shingle, again, with debris accumulation. Again, the vulnerability isn't the Class A roof in these cases, it is a siding. In the big picture, the siding is a non-combustible siding product. So that siding isn't such a big deal because it can usually handle this kind of thing too. But then you got to worry about this area right here where the dormer meets the main body of the roof. This is fascia and then some sort of soffit. Is that going to be okay? So, I mean, the message is always keep debris off your roof, but given this kind of construction, you want to look at what can be vulnerable next to the roof. So if you have wooden siding all around, including your dormer, this is, I would argue, more cost-effective and bigger bang for your buck than maybe replacing all your siding. And we're going to get to that in a minute because there are things you can do next to your house to help the wooden siding or the combustible siding there. Yes, sir?
You have a lot of pictures of small amounts of fuel on the roof, pine needles, things like that. So it looks like it makes a lot of sense. Then when we get a warning there's a wildfire that's nearby, you may have several hours, you may have a day before you can decide how dangerous it's going to be to your structure. And it's seeming like the first thing you should do is get up on the roof now fast and get all that loose fuel off. Is that true?
Well, so it comes down to, so everybody heard that question. It comes down to how much time you have, but I would argue that, your job is to not wait until you get the threat notice, but to keep doing this along and along. If you are in that position and you have time to prepare to leave, to evacuate, there are a lot of things that you should be doing, could be doing, and this definitely could be one of them. But I think maybe by the end of the talk, maybe you would know in your head for your house what the most important things might be. We'll talk about many things during the course of well, we got all night, right? So I'm going to leave this pretty soon, but chimney chase is another example where you can have this kind of vulnerability. And, I think if you have a brick chimney, then it's not the deal that if you have a chimney chase with a combustible cladding around it. So, and this actually picture is a Southern California fire back in 2007. This house was not lost, but it could have been. And it was the chimney chase that where embers accumulated at the base of the wall. The other thing I think that is interesting that I think would be of interest to you too. normally, and when you look at your house, your code says have clearance from the ground to the start of your siding. Then there should be something non-combustible in between. And typically it would be your concrete foundation. You can have pretty minimal clearance at a chimney chase, for example, or at a dormer for that matter. And so in these situations, you can have not much debris accumulation, but embers can accumulate. And if you have very little clearance between where your siding starts and your roof starts, where your siding stops and your roof starts, then you can have an ember accumulation at the base of the wall, and you can have a direct ignition of the combustible siding. So something to consider there. Okay, we're going to talk about keeping on the complex roof. This is a skylight shot. I can guarantee you this is not your skylight. So like the window, the most vulnerable skylight is one that's open. So if you have an operable skylight, that would be one thing you would be doing. Closing your windows would be one thing you're doing as you're getting ready. There's a couple of kinds of skylight, the kinds that have the plastic dome. The dome types have a plastic light, and the flat ones are tempered glass. So their common recommendation is to have a glass one because of its resistance to heat. But I guess I'd like to talk about the vulnerability of a skylight as a function of slope, of roof slope. So the upper left and the lower and the middle right picture, these are glass skylights, but they're on relatively flat roofs, and there's a lot of debris on the glass. So ember ignition likely, able to resist it maybe. The easier solution, though, is to try to not have debris accumulate or clear it off if it does. The large tree next to your home that doesn't have branches that allow for ladder fuels to get up into the crown, that's not likely going to ignite by itself, but it'll drop stuff on your roof. So, it's going to increase the maintenance factor on your part to keep debris off of your roof. And the lower left-hand picture is a dome skylight on a relatively flat roof. Debris doesn't accumulate on it so much. So from that perspective, it's hard to say that one is inherently better than the other. And this next slide is showing debris accumulating next to a skylight. And the lower right hand shows you the kind of metal flashing that is there for water, water durability purposes, and to keep water out of your house, to protect the skylight framing, whatnot. And so it's not necessarily a bad thing to have a little bit of debris accumulate, and this metal should be able to resist that kind of buildup. So you want to keep debris off your roof. But there is some protection in skylights. And so from a problem perspective, it seems to me that debris accumulation on the top of a flat skylight is a problem. And then where a dome skylight would be, I think, more vulnerable would be on a steep slope roof where you have vegetation or other combustibles nearby where that burning vegetation could actually provide a radiant exposure to that skylight because it's more like a wall than it is a roof because it's so steep. So if you have a steep slope roof with a skylight on it, look, in your mind, look through the skylight to see what it sees. And if that thing starts burning, how far away is it? How long will it burn? And what kind of exposure will that skylight likely see? So this is just a tempered glass bug. If it's an etching on a window that lets you know that there's tempered glass. So you can look at all your windows and skylights if you have glass in them and see whether you have that little bug. It'll tell you whether it's tempered or not. Tempered glass performs a lot better in a fire than regular old annealed glass. Okay, this is another roof edge issue, gutters. If you have a simple roof or a complex roof, you're going to have a roof edge that you could have a gutter on. This is another example of how a Class A roof can be bypassed. So this debris in this roof, in this gutter, if it ignites, it's not really exposing the roof covering per se, it's the edge of the roof. So what is your fascia like? What is the roof sheathing like? What condition? Can it see that sheathing or not? This is a metal gutter. So is a metal gutter better or worse than a vinyl gutter? Metal gutter is better. Why is that? It doesn't burn, okay. And a vinyl gutter melts, okay. So let's talk about that. A metal gutter doesn't burn. It'll stay put if there's debris in the gutter, and it'll provide a flaming exposure to the edge of your roof. So whether or not metal gutter is better is going to be a function of the condition of the edge of your roof. If you have a vinyl gutter with the same kind of debris loading, that debris is going to ignite. The vinyl gutter is going to detach eventually, pretty quickly, but eventually, and fall to the ground. And then the issue is going to be what's on the ground and how will it help, so to speak, it. So the best solution is no debris in the gutter, and so one thing you can do when you're getting ready to evacuate is to say get a kitchen drain mat deal or a sturdy sock, plug up your downspouts, fill your gutter with water, and that way it'll quench any ember that comes, and then let the water drain out later. So this is a picture from our lab, and it definitely shows the vinyl gutter detaching and falling to the ground. It shows the metal gutter staying put, and then it's all about the condition of the edge of the roof. So a vinyl gutter here, but you can see that the fascia is present and the roof sheathing is present, exposed. And so, if this was a metal gutter, then the vulnerability would be that fascia board and the roof edge. And the more, the worse condition of the wood at that edge, the worse your problem is. Decayed wood, more easily ignitable. It's lower density than sound wood. So, if this is your house, I'm sure it's not, but if this is your house, then this should be on your list of things to do, is fix this. So the one interesting thing that I'll show you a picture of later on that was, to me it was like up there and truly interesting because it was a pretty simple thing that was very effective, and it is a drip edge at your roof edge. So this is a gutter that has an integrated drip edge, and so this part of the metal slips under the roof, but this metal. So this can be part of your gutter, or it can just be a bit of angle metal that you would put underneath your roof and let the other leg come down your fascia board. It certainly makes up for bits of debris that might ignite. It provides protection to that roof edge, so there isn't seen bare wood anymore. And to replace your gutter it's a bigger deal than a piece of drip edge metal flashing. But that's pretty inexpensive, and it's very effective. So let's see. Well, we've seen that. So another edge of roof issue is this clay barrel tile or a corrugated metal kind of roof, where you have a gap between the roof covering and the roof deck. So here we see part of that end plugged, and this is not plugged yet. This was sort of a home repair job. This was actually a picture I took in Malibu a couple of 3 years ago. So the purpose of this bird stop is to keep debris from going up in there and to keep birds from crawling up in there and building a nest. And then during a wildfire, embers fall up in there and ignite that fine fuels and then provide a flaming exposure to the bigger wood members in there. So this is, again, a way for the Class A, in this case, non-combustible roof to be bypassed completely. It doesn't matter that it's a non-combustible roof because the embers bypass it. So you take care of that bypass situation by putting a bird stop. And this is a factory-made bird stop. And so I think the point is here, and so here that it's needs maintenance. It needs to be repaired because it's bent away from the opening. So you need to inspect and maintain these things as you go along. Don't forget your ridge. In this case, there's an opening up here that needs to also be stopped because embers can get in there. You may not get a bird in there, but this is an opening in a metal roof that has an opening smaller than that opening here. And you can see there's a lot of debris that just sort of gets in there over time. You're not going to know it. You're not going to be able to clean it out, but embers are going to be able to find their way in and ignite this debris that has come in over time. So it's better to plug up the openings to keep debris out and embers out. So the other thing about gutter covers, about gutters is maybe using gutter covers. Some gutter covers, and we saw this today a couple of times, is that it often allows debris to accumulate on the gutter cover or behind the gutter cover on the roof. So, I would argue that this Class A roof is better able to handle this kind of debris loading than the edge of the roof. So, in that matter, it's a good thing, but it doesn't really get you out of the job of keeping debris off your roof. Okay, so talk a little bit about vents. Vents are important because embers can enter through them and get into the house itself, into the attic, into the crawl space. We have vents on the side of our house that might be for a dryer vent or for combustion air makeup. There's a lot of openings in the wall, and there are many cases of ember entry into the house through these openings that have resulted in ignition and home loss. So, we have many kind of roof vents. In the California building code doesn't like vents that occur in the under eave area, and so they have these vents low down and higher up on the roof. But I think the point is we have some way to get air in and some way to get air out of an attic, and similarly for a crawl space and the other openings. So some research that we did at the lab not so long ago showed pretty clearly that gable-end vents and vents that had a perpendicular face to the flow of the embers was very vulnerable to ember entry. So gable end, if you have an open eave kind of construction, and vents in the blocking, embers can go in there. So you need to be careful there. So this is an open eave kind of construction. This is a soffitted eave or boxed-in eave. The ember entry into soffitted eaves wasn't so much. So the bigger culprit was an open eave. So this is, and one of the arguments for boxing in is the ability to, just by construction, to minimize ember entry. Inside your attic, combustible things are there. So embers enter. There's a lot of things in there, whether you put them there, knowingly, like magazines and newspapers, or just sort of shows up, construction debris, birds' nests, and the like. These things happen. So this is a video clip. We're going to see embers. We're going to be able to see a gutter fall to the ground here in a minute. This is a vinyl gutter, obviously. And then notice here embers collecting on the window screen. Window screens are very effective in keeping embers out, and they help reduce radiant exposure to the glass behind. So vinyl gutter didn't fall all the way. Here's this gable-end vent. And so here we are. This is a soffitted eave, and you're not seeing too many embers come in right here. Here's another soffitted eave. This is vinyl. This is sort of what's going on outside. You can see that area there. So far, it's kind of a boring clip. It's another kind of soffitted eave. Still not much happening. Another soffitted eave. You're yawning. Okay, gable end. So finally some action. So embers coming in to go any which way. Here's an open eave. Again, embers coming in. They go any which way. And this is the holes in the the blocking. Some embers coming in, not as much as that big rectangular hole, but still some. You can see all the embers outside happening. So the point, this is sort of showing by example the vulnerability of gable end type vents and vents and blocking compared to soffitted eave type of venting. And this is the other thing that was sort of interesting to me, and it goes back to the drip edge. If you just look at these two pictures, upper left and lower right, and the dark things on the soffit surface in the drip edge missing picture and the lack of dark things on the surface in the drip edge installed. So when embers were entering in the soffitted eave picture that you did see, they were coming in at this roof edge to fascia intersection through that opening, not through the vent opening, but through the opening. And so if you had that drip edge installed, that sort of blocked off that entry point. So it's argues pretty well for me to have a drip edge. And it's good from a moisture perspective, it's good from a fire perspective, it's just good. So this is to remind you that same picture, but here's some, that edge, that gap, and some embers that didn't quite make it in during the course of the test, but that's how they were coming in. Okay, so, screens, we say, how many of you know what size mesh screen you have on your vents? Quarter inch. So quarter inch is plenty big enough for embers to enter and to ignite things. 1/8 of an inch is also, but we recommend 1/8 of an inch at a minimum. If you have finer mesh screen, this is 1/8 of an inch mesh, and you can see that debris over time builds up in these. And so, the vents are there to perform a moisture management function, and if they get plugged up, then they can't perform that function. And so here we have painted over finer mesh, just like window screen mesh size. So once these things happen, it's not able to perform that function. So it increases the maintenance for you to keep it clean. So one thing you could do is prepare beforehand vent covers for these perpendicular kind of vents, gable end. If you have, this is an under eave rectangular vent, so in that location, dryer vents, something to cover those guys. Any vertical other vents on the wall. We saw today a door that was an enclosure to a mechanicals closet that had two louvered vents that were unscreened. So, screen those things, 1/8 of an inch at least, or prepare and be ready to install these guys. There are a number of so-called WUI vents that have been specially designed to resist the entry of ember and flame. These have been accepted for use by the state fire marshal, so the brand names are Brand Guard, Fire Guard, Vulcan. These are available commercially. These cost a lot more than 1/8 of an inch mesh, but it's not a deal killer usually. So they have these kind of passive vents. Let's see, I'll tell you, this has a baffle design. These things usually have screening and something else to help them resist fire and ember. So this has a baffle design. This has an intumescent paint coating on this honeycomb mesh plus some screening. And this vent here has a fuse link that'll close if it gets hot enough. So this one you'd have to see some heat to close. The Vulcan has to see some heat for the intumescent paint to close, and so they need some sort of energy behind them. The brand guard is strictly just a baffle vent with some screening. Yeah.
Vent that requires the heat in order for it to work. If you're dealing with embers that come in advance of flames and radiant heat, are the embers on their own going to be enough to trigger that vent?
Yeah, so the question is, for a fuse link, is that going to be enough? The fuse link typically needs 140 degrees, so an ember alone isn't likely going to do it, but an ember alone isn't going to make the intumescent paint activate either. Right. So I think these things you need to consider when you're considering if you have a situation where it might see flames, then these things would help. Anyway. And then there are some not passive, they're active closure devices. This is one that's commercially available that is made specifically for open eave construction where it's the door closes, so to speak. They have some that you would do it. They have some where you can just, you would have to do it regardless, but they have some where you would do it each vent, and then they have some where you can flip a switch and there's a cabling system that'll close. And then this is another one for gable end vent that's called Ember Armor. You can see it on here, but it has a door that is held up, and then you pull a switch, and it'll close it. And you don't have to go up into the attic to activate it. You have to go up into the attic to open it up again. So I think with these active things, you got to remember to open them once you've closed them, once the wildfire threat is gone. Okay, windows. So windows, we have the frame, we have the glass. Which one's more vulnerable, the frame or the glass? Glass. Did I tell you that? Good job. So the glass, far and away the most vulnerable. Is that across the board? No reservations. The glass is it? What are you wondering about now? Since I've told you that the glass is more vulnerable. Yes, sir.
Fire-resistant glass.
So that would make it less vulnerable, right? I mean, I guess my question is, fire resistant. So there definitely are a lot of different kinds of glass that would be better, but regardless, the glass. So I get your point. So the glass that we would typically afford as homeowners in a window, then that glass is more vulnerable. But you can buy super duper glass that is really hard to, it's expensive, that would then maybe make another part of the window more vulnerable. But the kind of glass that is available to the likes of you and me would be annealed glass, maybe laminated glass, and tempered glass, and other kinds of glass that might be in a skylight. But the common ones would be laminated, and a window would be laminated, tempered, and annealed. And any one of these three things in a window, they're going to be the things that are vulnerable compared to the frame. The only real issue would be a vinyl frame. And so if you have a vinyl window, then you want to make sure that it has this metal reinforcement, particularly if you have a hung window, like one that goes up and or down, and has that middle member. You want to make sure it has this metal reinforcement. And that keeps this deformation from happening. And therefore, if this deformation happens, then the glass falls out before it can break. So at radiant heat flux is far less enough to break the glass. This is happening, and it falls out, embers, flames come in. That's another story. Yes, ma'am?
Suppose you have dual pane clad framed windows.
So single pane windows are the most vulnerable. And then dual pane is better, and then dual pane with tempered would be better yet. But if you have the clad, meaning like a wood-clad window, in those cases, the glass is still the vulnerable part, and the cladding doesn't hurt or hinder. It's still the glass is the ticket. So, did that answer your question?
Yes.
Thank you. So I'll go back and spend a minute just talking about how windows are vulnerable and why this is the case, why the glass is the most vulnerable. And if you can just imagine some sort of radiant heat source outside of a window, and the green bars being the frame, whatever frame it is, then the part of the glass that the heat sees heats up more than the part of the glass protected by the frame. And so you have this temperature difference between the exposed glass and the protected glass. And this temperature differential causes fractures to occur at the edge of the glass, and it works inward. If you get enough of these guys working in, then it just cracks and fails. So that's what's going on there. So here's just an example of a firewood pile, no longer there, but a firewood pile maybe 10 feet or so from the building that ignited and broke windows on this particular home in this 2007 fire. So this is an example of windows being vulnerable where the siding, didn't play particularly, but it was this combustible material near your home that was actually the thing that made all the damage happen. So firewood piles being moved away from your house is a good thing. And firewood piles are things that burn longer than vegetation typically does. So we saw in the video the embers collecting at the screen. So screens are a good thing. They help sort of as an additional protective measure to keep embers out if you happen to forget to close your window, and they provide protection against radiant heat exposures to the glass itself. So they provide a two-prong protection. This is a fiberglass screen, and you can see embers building up on it. So even fiberglass, fiberglass is non-combustible, but these are typically plastic-clad fiberglass, and they work as well as metal. The problem with the plastic-clad fiberglass is that if it sees a flame contact exposure, then it'll fail, and then embers can readily enter and flame also in that case. So let's see, we're talking, I think we're going to talk, about curtains and curtains behind windows. So here we have, this is the Angora fire, some vinyl blind that had the fire on the end of the house. This was on the side of the house near that end, and there was some damage to the vinyl. This house survived, but there was a lot of damage to this side. Here's a lace curtain in a house. Now, so how many of you heard to remove your curtains or whatnot? And what's the likelihood, you think, of curtains igniting with window closed and window not failed yet? Pretty good? Not so good? We did a test to show this, and so here we have this radiant panel and some gizmos to measure the radiant heat on the back side, on the inside surface or the unexposed surface of the window, and we measured that heat, and here it is. So you don't need to worry about the units per se, but just remember these things, that on the radiant panel side, you had 35 units. And on the inside, the biggest number you had was sort of a little less than 11. So even without a screen, the glass does a good job of keeping radiant heat out. And then the screen, this is the blue line. So the red line is no screen, the blue line is a screen. But so you want to look at what was on the outside, what was on the inside, what was on the inside with the screen. So the glass does a good job, the screens help. But this isn't a very big number from a material perspective. It'll burn us pretty readily, our skin. But in this test, this is a cotton curtain, so it isn't an example with maybe a more vulnerable type of curtain material, but it took more than a minute after the glass completely broke and fell out for this curtain to ignite. So typically, things bad happen when the window breaks, when the glass breaks. And before that, you can certainly open your curtains. It's a good idea in case something happens, but it's not likely to ignite prior to glass breakage. Decks. These are one of a couple of kinds of attachments. I think if if your deck were to catch fire and fall off and roll down the hill, we would be a lot less concerned about decks. But the fact is that if decks ignite, then there's a lot of things next to that deck that can burn or break, like the sliding glass door, and the fire can burn to the eave. So there's a lot of vulnerabilities tied to a deck. And we're going to talk about the deck in terms of the deck itself, but then other things that might make a deck more or less vulnerable. So here's a small deck attached to a house. This deck has a wood plastic composites decking material, and as you can see, there's a sort of a steep drop off to the left. And so, what kind of exposures might this deck see, do you think? Flame contact exposure, maybe. Ember exposure, probably, if things were to ignite. So let's stand on top of the deck and look down slope. So, this may not be all this homeowner's property, but the fact is that if a fire ignites down there and burns up slope, then definitely the underside of the deck will see a flame contact exposure, and it will also see an ember exposure. So without knowing anything about the deck itself, we know that this deck is going to be vulnerable because of its location. And then there's a thing that we often do with decks, and that's store stuff under them. And so even without talking about the deck, again, per se, we're talking about other things that can contribute to a pretty nice deck fire. So this lumber storage place would be vulnerable to ember ignition pretty handily. And then, so if we choose to have this kind of stuff under our deck, then we might say, well, I think I'll enclose my deck, and that will solve the problem. And sometimes you just defer the problem someplace else. So here's the upper left is a vertically enclosed deck, and these decks are the gapped deck board kind of deck. So you have a lot of water that can still come through during rain and the like. So if you vertically enclose this kind of a deck, you need to make sure that you allow for the water in that inside part to evaporate somehow, or else you're going to have a rot problem, sooner than you have a fire problem. And the lower right is a horizontally enclosed deck. Again, you can see this. In this case, it's a wood plastic composite kind of decking product. A lot of wetting stains at the gaps, and no place for the water to go if they hadn't opened up this little part here. So the point here is that there's wooden things, even though the deck board itself may not be so decay prone, the support structure is, and then you have the metal hanger, which can corrode. So the point is, if you're going to enclose your deck, you got to make sure you address the moisture issues. And if you have a solid surface deck, then you might be in a better spot to enclose because you don't have the water coming through. But the solid surface deck is typically non-combustible anyway. We're coming back to these kind of terms again that we talked about earlier on. I guess my point is that, so this is a tunnel that we use to get the flame spread rating, but we also use this in California to determine whether or not you can call something ignition resistant or not. And we can use this term to help decide about siding and decking, for that matter. But you often see with materials that are combustible, you often see I have the material manufacturer will say I have a class A or B or C, whatever flame spread rating. This is just the piece of equipment that you use to build it. But the thing that we also have, which I think in this state is a nice thing, it's a pretty good thing, is the Chapter 7A of the Building Code that has with it some test standards that a product has to pass to comply. And where this has helped the most, I think, is with decking. So this is an online document. It's a free download, and it gives products that comply with the state requirement. And requirement says that you have to have a certain amount of, there's certain properties that the decking has to meet in order to be sold in this state, and you can find out what these are here. So it's sort of neither one of these kind of terms that we're looking at here, combustible. They're all combustible for the most part, but it's a different way to think about fire resistance. And this is just a sort of a final picture showing the difference in performance between something that meets this test and something that it doesn't. So here we have, on the far right, we have a wooden deck. This is a redwood deck. This is a compliant wood plastic composite, and this is a non-compliant wood plastic composite. And they all started out with this Class B brand we saw earlier on for the roof test. So they all started out as pretty small fires, and in about 30 minutes, these two guys, the compliant products, had gone out, and the wood plastic composite that has some fire retardants in it, and the redwood deck untreated, they both look about the same. But the non-compliant product is a much bigger fire now. So, you know, you can do a lot of things for your deck, but we've finally gotten to the deck board itself and the things you do to the deck board itself. If you have debris under the deck like that large wood pile, it's not going to matter which one what kind of deck you have. It's going to burn. You're going to have a deck problem. So I would say that, you know, your deck issue is going to be solved, so to speak, by addressing the exposures it's going to see and by not exacerbating the kind of exposure that it needs to see. So if you're on a slope, you need to do veg management around it. If you insist on storing, then you need to do something that protects that, and that could be enclosing, taking care of the moisture problem. It could be not having your combustible materials there. And then you definitely can do something with the type of product you have. And these are things under the deck. On top of the deck, you have furniture, you know, so when a wildfire is threatening and you have a lot of combustible furniture, you know, the thing to do is to move that furniture, particularly, say, the cushions that you might be sitting on, take them inside, for crying out loud, or something, or just get them off the deck. So here's just, I think we saw this picture before, but it's embers igniting stuff on the deck and stuff under the deck. This is just another example of things to be aware of that are sort of maybe small issue things, but debris accumulates between the deck and the wall, get rid of that. Debris accumulates between the deck boards, get rid of that. And then sometimes debris can accumulate on these, maybe a more complex deck where you have step down. This horizontal surface under the deck can collect debris, ember ignition, so it's a flame contact exposure. I think what we want to minimize is flames touching combustible things. Fences. So the idea here is during wildfire weather, you know, usually hot, combustible things dry out even more than they might be. Fences, either because of the material, like the lattice, which is pretty readily ignited, flame contact from fire burning up to them, and then burning to the house. So you want to get rid of this combustible part that attaches to the house, particularly if you have a combustible siding. This is another example just showing, again, in this case we're showing the contribution also of decayed wood. So here we have a fence attaching to a shingle-sided garage, but the way that the detail is where the vertical members connect, it's like a pond down there. When it's raining, there's no place for the water to go. So you have decay developing in this area. You have debris that can develop in the same area and embers that'll land in the same area. So you can have an ember ignition, and then these are pretty small pieces, easily ignited, move to the siding, ignite the siding into the house, or the garage in this case. And so a non-combustible part of the fence, even if you have a combustible fence attached to it, would be the thing to do. Finally, siding. This is sort of the next to the last thing. The last thing is you walking out the door. Siding, a couple of things. There's two things that we worry about with siding. One is penetration of the fire through the lap joint. In this case, it's a horizontal lap joint. Get into the stud cavity. Not so good. And then flame spread up the wall. And then when flame spreads up the wall, whether or not it penetrates at a lap joint or not, you're just sort of spreading the problem someplace else, to the window, to the eave. And so again, this points to particular, so this is a combustible siding product, obviously. This is a non-combustible fiber cement product. They both had the same exposure at the base of the wall at the beginning of the test. So this one sort of went out, no problem. This one ignited and burned up and through. So in this case, you would have two things to worry about. This part, the flame through into the building cavity, into the stud cavity, and then up the wall to whatever it sees. So this is how siding can be vulnerable. This is a picture of a test I did. When I was with UC, I did some fire demonstrations around the state. And this particular one, we were looking at the performance of a gel product that was applied. So I often use corner sections. This is a corner section. So in this case, though, both of these corners have the same kind of siding. And this one had a piece of plastic on it, and this one had the gel coating applied. And so gel coating on the left, no gel coating, just raw wood on the right. And then two B brands at the base of the wall. And this is sort of along the way, but not at the end. So this eventually ignites and burns all the way up the wall. This one is almost out. This is the gel side. But you'll notice that it did burn through. So depending on the exposure, you can still, a gel-clad wall can still fail if the exposure is big enough. So even though this does provide more protection, you can see that it's a better performer. It still didn't protect the house in the sense that the siding still burned through into the stud cavity. So it doesn't give you a buy on doing other kind of defensible space things around your house. And this is the culprit. So this is the gel product before the test, and this bit was missed. And so this is unprotected. This happened to be low down where you might expect it to be missed. So I think this is the issue. One of the issues is hitting everywhere you need to hit and knowing where you have to hit, and acknowledging that the kind of exposure that siding is likely to see isn't a straight-on blowtorch. It is a from the bottom flame contact, and that's what caused this particular failure. The other unknown is if you apply a gel product and then evacuate, likely the fire is going to be coming later. Let's hope. And how much later is going to be a function of how well this is going to work, because it'll dehydrate and become less effective with time. So if you applied it, left, and the fire came right then your house might be protected, but you're going to be in trouble. And this is sort of near the end, still talking about siding in a way, but this is the flame spread up the wall with an open eave construction. So this is a study I did while I was still at UC, looking at open eave versus soffitted eave construction. So open eave ignition, so the gas burner is intended to mimic some sort of combustible thing at the base of the wall. It's not a plant, obviously, but because this burned for several minutes. But once the eave ignited, there was lateral spread to the sides very quickly, and so you had ignition quicker than with the soffitted eave, as we're going to see, and then lateral spread in the open eave configuration. So heat does trap in this open eave area, and then move laterally once it ignites. This is a soffited eave or boxed-in eave, and this is a combustible plywood product. It definitely ignites, but it took longer to ignite, and it didn't spread laterally nearly as much. So given the results of the ember entry testing earlier that you saw, and this flame contact, this flame contact, many people will say, well, if your eave is seeing this, then your house is probably not long for the world anyway. And there's some truth to that, but this does provide additional protection. So in my mind, softening or boxing in is a really good deal from the flame contact perspective, but also more importantly from the ember exposure perspective. A garage door, these sort of last minute things. We tend to store combustible things in garages. Your garage door can be vulnerable because, particularly in older garage doors, there's sort of leaky or gaps at the edges and the bottoms and the tops. Embers can easily enter through these gaps. So if you have an older garage door in particular, you want to weather seal it to stop embers from entry or to minimize the number of embers that enter. Okay, this is truly, I almost promise, the next last slide. And I just wanted to, this is sort of a thinking and a discussion with you. So this is the Santa Monica Mountains document. How many of you have seen this? Okay, so after today's talk, and after you listening, I want to just walk through these fire prevention tips, and I want to hear what you have to say. So first fire prevention tip, use ignition-resistant construction materials. So after today, what would you like to, does that make sense to you? Can you name some products that are? Name me one product that's ignition resistant. Those of you there. Treated wood, thank you so much. Fire retardant treated wood, that is ignition resistant, that meets the definition. Fiber cement, stucco, they are non-combustible, yes sir. Okay, so let's see. Install approved baffle attic vents. What does that mean? So would you hear one of the new WUI events when you hear that, or when you read that, or would you say that means what? That's right. Yeah, they're about $30 a pop. So.
Expensive, and it also stops airflow. I actually had them come out and look at my house and have them tell me that I needed to add in another 30% more vents.
So, so the question or the comment was about reducing airflow and as a function of the way that we evaluate the amount of opening space for air to enter, and all of these vents and finer mesh screen all reduce that opening. And so no matter what you do, you may have to add something. But all of these tend to reduce airflow, you're right. Box-in eaves and bird stop tile roofs. Everybody on board on that? Yeah. Good. Convert from single pane to double pane windows. So good thing from a fire perspective, good thing from an energy perspective. Install non-combustible siding. Name me a non-combustible siding product. Hardy panel. The generic for that is fiber cement. Install Class A roofing materials. All on board.
Is that so your basic composite roofing material you get at Home Depot and all that stuff, is that always Class A roofing?
The asphalt comp roof is, in this state, it's always Class A. The difference is the fiber in the asphalt composition fiber, and in this state, it's always going to be fiberglass, the fiber. A small amount of production around the country, and I think it's almost non-existent now, would be a cellulosic-based fiber, and that's a Class C. So, let's see. Use ignition-resistant deck materials. What would that be?
Timber sill.
And what else would work? Treated wood. But But what we have in California, though, are the state fire marshal requirements, and you get it's a little bit complicated because you have a Class B flame spread, which means it's not an ignition-resistant material, but it still complies because of other things. And I would take the other things actually myself, because the other things are the amount of heat that is released when it burns, and the fact that it puts itself out. There's other things that make it better, I think. So anyway, so let's see. Use non-combustible fencing materials. So what would that be? Chain link, yeah. Chain link, cinder block, a framed fence that has stucco cladding would be non-combustible. So there's some options there. Wood lattice fence, chain link fence that has all nice kinds of woody climbing vines all over it. Do you defeat the purpose of the non-combustible fence? Thank you very much. Ignition-resistant outdoor furniture. So that's a hard one. You can have metal furniture, you can have wood furniture, you can have plastic furniture. Metal is non-combustible. None of the others are ignition-resistant. Take your cushions and get them inside. Take the put them the other things as far to the edge of the deck as you can, those kind of things. Seal openings in the outside, like garage doors and doggy doors. Everybody's all good on that? Remove combustible materials adjacent to structures. That's the hardest thing to do, but it's really important. So I think we can talk about leeway. It's the woody vegetation, it's the combustible mulch. These things are important. And if you're looking at your siding, you want to look at that at the bottom of the siding, particularly if it's combustible. You want to make sure you have an adequate amount of non-combustible clearance between the ground, between the top surface and the bottom of the siding. So if you have 4 inches of mulch and a 6-inch foundation, then you have 2 inches of clearance, and that's not a lot. Okay, let's see. So consider purchasing fire retardant foams or gels. So gels, let's stick with. What's the upside of gels? What's the downside of gels? So I really appreciate your attention and for you staying here and being here and actually staying here. So thank you so much.